Hi all, welcome to my YouTube channel Easy Coding with Ankit. Today's we will solve Leetcode problem. Let's get started. So today's problem is rotating the box. Problem number 1861. It's a medium type problem. Let's take this question in Leetcode. Rotating the box. You have given an M cross N matrix of characters box representing a side view of the box. Each cell of the box is one of the following: a stone, a stationary obstacle, and empty. Stone is donated by has, obstacle is donated by star, and empty is donated by dot. The box is rotated 90 degree clockwise, causing some of the stone to follow due to gravity. Each stone fall down until it lands on an obstacle, another stone, or bottom of the box. Gravity does not affect the obstacle position, and the inertia from the box rotation does not affect the stone horizontal position. It guarantees that each stone in box rests on the obstacle, another stone, or at the bottom of the stone. Return M in cross N matrix representing the box after the rotation described above. So what we have to do? We have to first rotate the box 90 degree. You can consider this as a matrix, two-dimensional matrix. The size of that is m cross n, and result you can see we have to return n cross m. So that row and column will be swapped. First thing that, so what we can do, first we have to create a matrix with a swapped row and column. So we will use n as a row and m as a column, as we have given a box with size of m cross n. In the example also you can see we have this box 1 into 3, 1 row, 3 column, that is rotated. Now it become 1 column, 3 row. So it just we are swapping the column and row value. And once we do that, we also have to place our stone. Stone you can see we are donating with has. So in the input it contains has dot, that means it's empty space, then has. So once we move it this, the last one you can consider from last one, last has is there at the bottom, that is correct. Now second has, which is at the first, is came at the middle because we have an empty space. So once you move, due to gravity, the stone is fall down and it came at second position instead of the first position, because you can see the stone can rest on the obstacle will be donated by this blank color, gray color. That means it is an obstacle. At that place they can place, or another stone, that is we are doing in the first example, or at the bottom of the box. If it is the bottom of the box, that also. But if it is dot, that means empty space, then it will come down. So that is happening in the first example. Second example, you can see the obstacle is donated by star, two stars, and because of that, first we have rotated, and then for first column you can see both are in same way only, but for second column it is came down because due to gravity. So that's is our problem, and we have to first rotate, and we have to also take care that due to gravity a stone will fall down. It's a metric problem, and we will be using two pointer concept to solve this problem. How we'll solve it? Let's look this into. Let's consider this example and see how we will do it. So I have taken the same array where first we have same matrix where we have first has, that means stone, then dot, that means empty space, then star, then obstacle, and then dot. And in second row again has star and dot. Answer, final answer you can see at the last. First it will become has star dot, like that. In the second row it will be rotated 90 degree. And second case, from bottom if you check, First it is coming dot, then star, then hash in place of dot. Because of gravity, it is fall down. So how it is falling down? You can see in the middle. First I am keeping at that same way only. I'm not using the gravity concept. So stone is not falling. After that, I have to take care that stone is falling, and then it will come at the second. So only one stone will be fall. Rest will be in same location as we have in the given input. You can see the index also, how index is getting changed. First and last you can consider. First case, the index will be 0 0. That means the first which contain has, then 0 1, that is empty space, that is dot, then 0 2, that is star, then 0 3, that is dot. Now this will be placed at where? We have to place at 3 1. Like first you can consider 0 3, that will be placed at 3 1. Then 0 2 will be placed as 2 1, that means this is star. Then 0 1, that will placed at 1 1, and then 0 0, that will placed as 0 1. So basically column is getting changed and row is also getting changed. In place of 0 3, we are using 3 0. That means column will be used as a row, and row will be it row will be considered from the bottom. So what we will do, we will take the um, row number, like box dot length minus, and whatever index we are, row value we have here, that is 0, that we will minus it. So we will get 1 here. So you can see the row is 2, 2 minus 1 will become 1, and 1 minus 0 will be 1 only. So that we will be using here. And how we'll do it? First we will create our new rotated box with the swapped value. Let's create that. What we can do, we can take this as MNN, or we can say it as a rows, that will be box dot length, then calls, that will be box of 0 dot length. So I got the calls, I got the rows and calls from the box, and we will swap this and create a new box. We will name it as a char, as is a character matrix, char array, rotated. Row will be changed, row will be used as a calls, and then call will be as a rows. So that we are swapping it. You can see rows and call is swap, and based on that we have created. Just like it is mentioned in the description, that as given the length of matrix is m cross n, we will be returning n cross n, and that we have to return it from this method, rotate box. So that is done. We have created a rotate box. Now we will loop over the box. How will loop over it? We will take first pointer row from 0. Row will be less than rows, and row plus plus. That we have to take, because row will be we will be considering from 0, then 1. In the second example, you can see first we will try to place the first row values, then second row value. So I'm starting with 0, and I will go till the length of the rows. So that is, in second example it is 1. So till that I will go. Second example is 2, so it will go till 2. Now inside that, as I have to take care of this gravity case, we will start column from the bottom instead of the top. So we will take int call equal to calls dot calls minus 1, comma, we will take one more variable. I said this is a two pointer concept, so we will take two pointer. Row you can ignore, call, and one more is fall stone index, we can name it. That value is also same, calls minus 1. These two variable I will take. These two we can consider as a pointer, and based on that we will be taking care of the gravity. If it is empty space, then it will be fall down. and then call is less than, call is not call is greater or equal to 0, comma, call minus minus, because we are taking from the bottom, so we will be doing call minus minus. So that's our for loop, two for loop. Inside this, what we will do by default, what by default we will place an empty space. You can see wherever there is nothing, it is showing with a dot. So by default what we will do, we will be setting, putting our default value, that is empty space, and empty space where we will place it. First row will become call, and row value will be rows minus 1 minus row. There we will place dot. This is the default value we will place, that is empty. And where exactly we are placing? Now when we move data, when we move stone, it will be stored at column and rows minus 1 minus row. Basically we are swapping the index value. If you consider the first example, now we are trying to put stone at the last place, this one, which is 20 index we are placing, try to place stone. First what we are doing, we are putting dot here, and then we will try to check if box of row and call is not equal to dot, then we will do something. If it is equal to dot, then we don't have to do anything, because by default we already set the dot value here. If it is an empty value, then we don't have to do anything. So that condition we are checking here. If box of row or call is not equal to dot, then we have to do something. What we will do it here? First we have to define where exactly we have to place our stone. We'll be using fall stone index, because we have to take care of gravity. And what we will do, fall stone index, that we have to decide where exactly we have to store. Either we will use fall stone index, or we will use call, which value we will be using. What we will do, call, you can see always we are decrementing it, but fall index, stone index will be decrementing once we will have some value. Either we have a stone or either we have this obstacle, then in that case only we will be changing those values, and that's why we have this if condition. And inside this, what we will do, we will check if box of row and call, box of row and call is equal to star. Star means it's a obstacle. If it is like that, then we will be using call, else we'll be using fall stone index. Means if there is an obstacle, then whatever column is there, that we have value we have to store, because we don't, that time we don't have to take care of gravity. But if it is has, then we will take care, because of fall index. And this value, you can see we are not changing it, we will be changing once we set this value. So we'll be setting now rotated box, fall stone 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 index, and rows minus 1 minus row equal to box of row call. So whatever value we have box in it, and once we do that, then only we will change fall stone index. So whenever, if there is a value which is not equal to dot, then here we will do minus 1. Then only we are decrementing fall stone index. Otherwise we are not decrementing it. By default, call will be decremented, because we have to take care of sequence on also, but fall stone index will be decremented only we when the value is not equal to dot, that term only, and that's how it will take care of falling condition as well. At the last we are returning it, so that's the whole logic of rotating the box and taking care of gravity. Let's run the code. You can see it is working fine for all three test cases. Let's submit and check if it is working for all the test cases or not. Yeah, it's working for all the test cases as well. So you can see we are using two pointer concept. One pointer we will always decrement it because if we are try to put the data from one index, then we have to decrement that to next index. But stone index will be decremented only when if it is not containing in dot. If it is not containing in dot, then only it will be decremented. Otherwise, we don't. So you can see here if it is dot, then call value will be decremented. But here fall index will be not decremented. So next time when we try to place it, we will place this hash at this position, second position, not at first position. So to take care of that, we have written this condition. Let's talk about time complexity. Time complexity of this algorithm. Here, time complexity of for loop is m. We can take this as a m, and this case also is n because we are taking care of column here. So the total time complexity is m into n, just like printing the matrix. And space complexity we can say uh, m into n because we are creating a new uh, n into m basically. Space complexity is n cross n because we are creating a new array with the size of n cross n. So that's our space complexity, and m cross n is time complexity. That's about rotating the box. Thank you for watching my video. If you like the video, please give a hit and also subscribe my channel. Thank you.